Shri Gurubhyo Namaha. Welcome to online class. Today we are going to discuss about one of the periodic property of the periodic table is electron affinity. So what is meant by electron affinity? So the electron affinity is the amount of energy released when the gaseous atom gain an electron. So electron affinity is the amount of energy released. The amount of energy released when the gaseous atom gains an electron. Gains an electron, it becomes anion. It becomes anion is called what? Electron affinity. Affinity means what? Attraction. So here the atom capable of attracting new electron into the atom to become what? Anion. So this can be measured by kilojoules per mole. Kilojoules per mole. So why some of the elements are capable of attracting the electron? For halogen, the halogen has the general electronic configuration ns2 np5. So to attain the octet configuration, the stable configuration, if they attract one electron, if they gain one electron, they become the octet configuration ns2 np6. So all the halogens are capable of attracting one electron to attain the octet configuration. So this is called electron affinity. And for the noble gas, noble gas has the electronic configuration ns2 np6. ns2 np6. So the noble gas cannot able to attract any or gain any electron. So the electron affinity of noble gas, is 0, always 0. The electron affinity of noble gas is always 0 because it is not able to gain any electron due to octet configuration. Now we will compare the electron affinity along the table. So along the table already we know that the atoms are arranged, horizontal rows are called periods and the vertical row is called column. So along the period the electron affinity is increasing. The electron affinity is increases. Why it increases? Because if you go for the first group element, the first group element has the electronic configuration ns2 ns1, the first group element has the electronic configuration ns1, 1 electron. If it gain 1 electron, it will not attain the octet configuration. And if you come to this p block element, the general electronic configuration ns2 np1 to 6. So here the first group of the p block element in p orbital 1 electron, and here 2. If you go for the 17th group, halogen has the electronic configuration. Halogen has the electronic configuration ns2 np5. So that the halogen can easily gain one electron by releasing energy. It gain one electron, become one anion. So that the halogens can be exist as what? F minus, Cl minus, Br minus. And in the 18th group, element, the electronic configuration is ns2 np6, completely filled orbital, octet configuration. So that they cannot accept any electron. They cannot able to accept any electron, so that the electron affinity for the 18th group elements is 0. If you down the group, due to increase in the atomic size, the electron affinity is decreasing due to the decrease in the nuclear charge. So, the attraction towards the nucleus is less due to increase in the atomic radius or the size of an atom. If you compare the atom down the group, the size of an atom is increasing. If the size of an atom increases, they are moving away from the nucleus. So, the attraction towards the nucleus and the outermost electron is very less. So, the electron affinity is less, decreasing down the group while compare this. So, these are all about the electron affinity. And next periodic property is electronegativity. So, the electronegativity of an element. What is meant by electronegativity? The electronegativity of an element is measured of the tendency of its atom to attract the shared pair of electron. So, for example, HCl. The electronegativity, while compare the electronegativity, already we learned that the electron affinity is more in the halogen. So, due to this, it attracts the electron. So, here how this bond is going to be formed by the covalent bond, mutual sharing. Hydrogen and chlorine has to give each one electron by this the bond. So, there is no charge or due to the electronegative nature, the chlorine attracts the electron of hydrogen. So that electron cloud towards the chlorine atom and electron deficient. There is electron deficient site created around the hydrogen atom. So, the electron deficient site created around the hydrogen atom. So, what is meant by electronegativity? The tendency of an atom in a molecule. So, this is a molecule. HCl is a molecule. So, tendency of an atom in a molecule, one of the atom in a molecule have a tendency to attract the shared pair of electron. So, due to this, the partial charge. So, more electron clouds towards chlorine. So, the partial charge is created around this and the partial positive charge is created around this. But they are not considered as an ionic compound. Ionic compound means completely they lose electron and completely they gain electron. Here, due to more electronegative nature, the chlorine have a tendency to attract the shared pair of electron towards itself. For the homodiatomic molecule, hydrogen, if you compare hydrogen molecule is formed by two hydrogen atoms, both are equally electronegative. So, here there is no charge created, polar ends is not created. For chlorine molecule, the chlorine molecules also formed between chlorine atom. So, both have the same electronegative nature. So, here there is no formation of partial charges. Only if the molecule in a molecule they differ in their electronegativity. So, in that case, the more electronegative atom attract the shared pair of electron towards itself to form the partial charge. So, the electronegativity can be used by the scale, Pauling scale. The electronegativity can be measured by using Pauling scale. Using the Pauling scale, we can predict the nature of the bond. We can predict. So, here we can see that HCl is the covalent bond. Covalent molecule means there is neutral atoms only present, but due to electronegativity, the partial ends are created. So, based on the electronegativity value, we can able to predict the nature of the bond. How to predict the nature of the bond? Now see this. So, now listen. The two elements, the electronegative value. See, the electronegative value is taken as what? 1.7. Based on the Pauling scale, the electronegative value is 1.7. If the two element in an atom, if the two element means, for example, hydrogen molecule, hydrogen atom, the two elements have the same electronegativity, they can show 50% of ionic character and 50% of covalent character. And next, if the electronegativity is less than 1.7, so the compound can show what? Covalent nature. Less than 1.7, they are purely covalent compound. If the two elements have the electronegativity, so now you first one, you see this, the first case, the electronegativity is of the two element is 1.7, then the nature is 50, they can show 50% of covalent nature as well as 50% of ionic nature. And then next case, if the electronegative value is less than 1.7, if the electronegative value is less than 1.7, then the molecule can show purely covalent. And next case, if the difference is greater than 1.7, if the difference is greater than 1.7, the bond is formed as what? Or the compounds are purely ionic in nature. So, based on this, if the two atoms are equal, to 1.7 means they can show 50% of ionic and 50% of covalent. If the less than 1.7, they can show what? Covalent nature. They can show covalent nature. And then greater than 1.7, they can show what? Ionic nature. So, based on the Pauling scale, we can predict the nature of the bond or the nature of the molecule. So, these are all about the periodic property of the periodic table. Thank you, children.